Hello friends, welcome back to my YouTube channel. Today I will continue my discussion on distillation. This is part 21 of that discussion, and today again I'll be continuing the discussion on McCabe method. And in this discussion I'll be talking about the intersection of operating line of rectifying section with the diagonal line. In my previous video on McCabe method, I have discussed how to get the equation for the operating line for rectifying section with the use of assumptions that are made in McCabe method. Now we will understand, or we will get the point of intersection of the rectifying section line with the diagonal line on the xy plot. Finding this intersection point is necessary in order to draw the operating line. So let us start the discussion. First, let us understand the distribution diagram, which is nothing but xy plot. It is also called equilibrium diagram. So let us first understand what is this. Okay, so we are going to consider a case where there is a liquid solution of two components, A and B. That is, we are considering a binary liquid solution which is in equilibrium with the vapor mixture of the same two components, A and B. Out of this A and B, A is the more volatile component. What is the meaning of this? A has lower boiling point and it has higher vapor pressure. Lower boiling point than that of B and higher vapor pressure than that of B. Okay, so in that way A is the more volatile component. X and Y in our discussion, these are mole fractions of A in liquid and vapor phases respectively. Mole fractions. X is mole fraction of A in the liquid phase, whereas Y is mole fraction of A in the vapor phase. Okay. Then each XY pair, that means for a value of X there will be corresponding value of Y, and each such pair define one equilibrium state, and collection of many such pairs, many such XY pairs will be nothing but the vapor liquid equilibrium data, VLE data. We call that as VLE data. So VLE data is then a collection of many such pairs. Okay. Now then, the distribution diagram that I am talking about is nothing but a plot of this VLE data. So you have different values of X and then you have corresponding values of Y, and if you use that data to plot a graph, you get what is called the distribution diagram. So how the plot is drawn: X is plotted on the x-axis, that is mole fraction of A, and the liquid phase is plotted on x-axis, and the equilibrium Y values, that is mole fraction of A in the vapor phase, that is plotted on y-axis. So the resulting curve that we will be getting is the equilibrium curve. So this plot will give us equilibrium curve, and that diagram is the distribution diagram, or um, the equilibrium diagram, you can say, the diagram that describes equilibrium between the liquid phase and the vapor phase. Okay, so after knowing how to get the distribution diagram, now let us look at the distribution diagram. So you have where we will be plotting x, that is mole fraction of A in the liquid phase, on x-axis, and y, that is mole fraction of A in the vapor phase, on y-axis, on the y-axis. Now the scale will be on x-axis, 1 centimeter is equal to 0.1, and on y-axis also the scale is 1 centimeter is equal to 0.1. So what I mean to say is we are going to choose a scale where it is same on both the axes. Okay, so you'll be getting a square plot in that case, and this will be the diagonal line. Okay, and then the plot will be a curve which we are calling as equilibrium curve. So this yellow curve is the equilibrium curve, and this is the diagonal line. So this is the equilibrium curve. Okay, so now our objective is to find operating line will be intersecting the diagonal line, the operating line for the rectifying section. Those who have not seen my earlier video, you please go and watch that video. You'll understand. We had there I had derived the equation for the operating line by considering the assumptions that are made in McCabe method. Okay, so now our task is to find the point where the operating line for the rectifying section. What is the equation of that line? It is yn plus 1 is equal to r upon r plus 1 into xn plus xd upon r plus 1. Okay, so this is equation of the operating line for the rectifying section. Equation of a diagonal line, in this case it will be yn plus 1 is equal to xn. Okay, so in order to get intersection points of these two lines, we will be solving these two equations simultaneously. That is the idea. Okay, let us go ahead. Now let us get the intersection. Here OL is nothing but the operating line, and DL is the diagonal line. I have used abbreviations. So equation of the operating line is yn plus 1 is equal to r upon r plus 1 into xn plus xd upon r plus 1. I am calling it as equation number 1. Then equation for the diagonal line, it is yn plus 1 is equal to xn. Now we are going to solve this equations simultaneously. So to find the intersection point, or to get the intersection point, equation 1 and 2, they must be solved simultaneously. So let us do that. So for that, what we will do, we will use equation number 2 in equation number 1. So this is equation number 2. We are going to use it in equation number 1. How are you going to use it? You are going to replace yn plus 1 in equation 1 by xn, which is true as per equation 2. Equation 2 suggests that yn plus 1 is xn, and now we are going to use it in equation 1. So in place of yn plus 1, we are going to use xn. So if we do that, we will get xn is equal to r upon r plus 1 into xn plus xd upon r plus 1. So in the next step, what we will do, we will bring this term on this side. So if I do that, you will get xn minus r upon r plus 1 into xn, that is equal to xd upon r plus 1. So this term which was on this side over here, now it is on the other side, the left hand side. So in the next step, what can be done, xn can be taken common out of this 2. So it will be 1 minus r upon r plus 1 into xn, that is equal to xd upon r plus 1. Further simplifying will give us r plus 1 minus r upon r plus 1 into xn, that is equal to xd upon r plus 1. So next what is going to happen, r minus r will be 0, so it will be xn upon r plus 1 is equal to xd upon r plus 1. So we get xn upon r plus 1 is equal to xd upon r plus 1, and now r plus 1 will get cancelled, and you are left with this thing. So previously we got this xn upon r plus 1 is equal to xd upon r plus 1. Now what will happen, r plus 1 on both the sides will get cancelled, and I will get xn is equal to xd. Okay, so on the x-axis, the operating line will be intersecting the diagonal line at x is equal to xd. Okay, so now with equation 2, what is that equation which was written previously? This is yn plus 1 is equal to xn, but xn is now xd, so that means yn plus 1 is also equal to xd. Therefore the intersection point, which is the intersection point is xn yn plus 1, and here both are equal to xd, both are equal to xd. So the intersection point of the two lines will have coordinates of xd, xd. Okay. So operating line for the rectifying section, you have this again, yn plus 1 is equal to r upon r plus 1 into xn plus xd upon r plus 1. So as you know, this is a straight line, equation of a straight line on xy plot, straight line on the distribution diagram, or we call it as xy plot. Okay, what is the slope of that line? This is the slope. So this equation is equivalent to y is equal to mx plus c. So this is a straight line whose equation is given by capital Y, y is equal to mx plus c, where m is the slope and c is the intercept on y-axis. So accordingly, if you compare these two equations, slope will be, that is m will be equal to r upon r plus 1, and intercept will be, or intercept on the y-axis, intercept on the y-axis, intercept will be on y-axis, intercept on the y-axis is xd upon r plus 1. Okay. So in order to plot the operating line, we need three points or three information. One is what is the intersection point with the diagonal line, what is the slope of the operating line, and what is the intercept made by the operating line on the y-axis. Okay, so out of these three, we can use any two information to plot the operating line. Okay, so next I'll show you how to plot the operating line. Okay, so we are looking at the intersection of operating line and diagonal line. So this is the distribution diagram or the equilibrium diagram. This is the equilibrium curve. Okay, now let us plot the operating line. We just saw the intersection point is xd. So on x-axis you have xd. So you can locate xd on x-axis. xd, if you remember, this is mole fraction of A, mole fraction of the more volatile component in the distillate. Okay, so we locate xd on x-axis, go to the equilibrium curve, go to the diagonal line, and if you from the diagonal line, if you move to y-axis, this will also be equal to xd. So this point is the intersection point of the two lines, that is operating line and diagonal line, and this will have coordinates of xd. Okay, the other information that we will be using is the intercept made by this line on the y-axis. The intercept is, as we know, this is xd upon r plus 1. Okay, so we now know that the operating line for the rectifying section will be passing through these 2 points, this point and this point. So we have 2 points, and then with 2 points we can easily draw the operating line. So this will be the operating line. This orange color line is nothing but the operating line for rectifying section. Operating line for rectifying section. And what is the slope of this operating line? It is r upon r plus 1. Okay, so that was my objective for this discussion. Here we have understood how to draw the operating line. For that we need to know what is the intersection point. We got that intersection point. We already know what is the slope of the operating line, what is the intercept made by the operating line on the y-axis. So with this information, now this is the way in which you can plot the operating line for the rectifying section. So with this I end my discussion for today. I hope you have understood the concept. If you have any doubts, you please let me know in the comment section. In my next video I'll be talking about operating line for the stripping section, how it gets modified if you consider the assumptions that are made in the McAfee method. For now, thanks for watching my video. Do subscribe to my channel, tell your friends to subscribe to it, hit the bell icon so that you'll be notified as soon as I upload any video. If you really like my videos, you please hit the like button as well. Thanks for watching this video. Have a nice day. We will meet in our next video.